All right, hi there. This is video number 26. And this is chapter 6, section 3. And this covers a whole bunch of different topics in polynomial functions. So it's all about finding roots, I guess, if we want to just be generic. Finding roots of polynomial functions. And the last video talked about synthetic division, and that's going to be used in this section again and every section in this chapter. So we'll just kind of break this down and see where we end up going. The first thing we're going to talk about is something called the rational root theorem. And this says there's a lot of writing, but there's actually not, the math isn't terribly difficult. So given a polynomial, f of x, you can generate a list of possible rational roots where p's, oh, there's like, you can't even see it there, hyphen. P's are the factors of the constant. And Q's are the factors of the leading coefficient. Comma, and all the P's over Q's become a list, or become a number bank of all possible rational roots. So let's see how this looks. So given f of x equals 2x cubed plus 4x squared minus 5x plus 6, what we want to do is find our p's, find our q's, and then we're going to make a list of p over q. And I'll show you how we do that. So the p's, let's highlight what those are. The p's are the factors of the constant. Well, remember, the constant is the number without a variable, and we want the factors of that number. So the factors are all the numbers that multiply to equal that. It's okay, guys. We're having a rainstorm outside. So all the numbers that multiply to be 6. 1 times 6, 2 times 3. That's about all we're going to get. So 1, 2, 3, 6. And you want to put these in ascending order. When you make these lists. Okay. Now the next one, I get a different color highlighter. Q's are the factors of the leading coefficient. Well, the leading coefficient is the number in front of the variable with the highest degree, right? So we want to take all of the factors of 2. Well, those are only 1 and 2. All right, so now what we're going to do is match up every P with every Q. So we're going to go 1 over 1, 1 over 2. 1 over 1 is just 1, so that's just 1. And then 1 over 2 is a half. And then we've exhausted those, so then we're going to go 2 over 1 and 2 over 2. 2 over 1 is just 2. I'm sorry, yeah, 2 over 1 is 2. Now, 2 over 2 is 1, and that's already in the list, so we don't have to repeat it. Okay, so we're only generating one number from that. Then 3 over 1 is 3, and 3 over 2. And then we have 6 over 1, and 6 over 2. 6 over 2 equals 3, but 3 is already in the list, so we're not going to repeat that one either. Now, all of these could be positive or negative. So we're going to make sure we have plus or minus signs on each of these when you make a list of rational roots. Now, if you were doing these for me on paper, that's what that list would look like. Okay. In varsity, they're going to have something that looks like this. Now, let's say in varsity, it'll look like this. They will already have, it'll say possible zeros. And then it'll say colon equals plus or minus parenthesis. So you're just going to put the list of numbers in with commas. So you'd say sorry. 1, comma, a half, comma, 2, comma, 3, comma, 3 over 2, comma, 6. So you put this list in without the plus or minus because they've got that already set up right there. Okay. Now, what is this? Possible zeros. What those are x-intercepts on the graph. Okay, x-intercepts on the graph is where a possible zero is what that is. So if you were to graph this thing, one of these numbers is where you would have an x-intercept. And that's what we're trying to find, is where x equals something. So what we're also trying to do is narrow down. If we were doing some synthetic division, we would take and use our coefficients for synthetic division, right? We would go 2, 4, -5, 6, backwards box. These would be the numbers here that we would be trying in our backwards box to see if we could get a remainder of 0 when we would do the synthetic division, right? So we would drop the 2. Our goal is to have a 0 here. And this is just kind of reminding you what our synthetic division was for. Goal is a 0 remainder. And if that happens, then we know the number in the backwards box is a 0, which means it's an answer to the function. Okay, so we're not actually solving this one. This is more to show you an idea of what the possible zeros are. So you're making a list of P's, a list of Q's, making a list of them, just literally every P, P over every Q. This P over every Q, this P over every Q, this P over every Q. Make a list of them. Then you would narrow these down before they had graphing calculators. The idea was to just guess and check and try these roots in here and see which one would give you a 0 in order to find out which one is a function, root of the function. All right, now the remainder theorem kind of uses that idea that we're talking about. So that's the next one that we're going to talk about. All right, let me throw some paper on here. So the next one that we're going to use is the remainder theorem. All right, the remainder theorem says if the remainder of a polynomial is 0, then the divisor, remember that's the thing you're dividing by, is a factor of the polynomial, period. So we're going to use synthetic division. And only put the remainder in as an answer if you're asked to do this. So if you're told to use the remainder theorem to list the remainder, here's how this is going to work. So you're going to be given a polynomial, 2x to the fourth minus 2x cubed plus 2x squared plus 5x plus 2, and divide it by the binomial x plus 2. A lot of 2's. All right, so first thing we're going to do is set up our, set your divisor equal to 0. Move the 2, and we get x equals -2, and that's going to go in there. Then we're going to drop down our coefficients. And again, make sure you have 4, 3, 2, 1, none, right? So we have every term, so we don't have to put any zeros in there. Leave a blank line, draw a line, drop your first number. Now remember, the idea here is multiply, put the product under there, add down. Multiply, add down. Multiply, oh, I made a boo-boo. I missed a sign. So when I add down here, when I multiply, -2 times -6 should be a positive 12, right? So this should be a positive 14. -2 times 14 is -28. I subtract there, I get -23. I multiply, I get a positive 46. I add down, I get a positive 48. Remember, the last number is always your remainder. And in varsity, when it says use the remainder theorem to find the remainder, you're literally just putting 48 in as your remainder. That's it. You don't have to put the depressed polynomial. Just a reminder, so this is just a reminder, depressed polynomial. If you had to write it, this is from the last section. Takes these, make sure you don't have a GCF, and you don't with this one being odd. You drop an x off, right? So you'd have 2x cubed minus 6x squared plus 14x minus 23, and then plus 48 over x plus 2 if you have a remainder, right? That's what your depressed polynomial would look like. However, that's not the question here. It is, what is the remainder if you use the remainder theorem? And it is just 48. Okay, so that's all that's happening. There's another question that's similar that says this. Use the factor theorem to determine if a binomial is a factor of a polynomial. So it says something like this. This question would look like, is x plus 3 a factor of x cubed plus 6x squared plus 8x minus 3? And so what the factor theorem does is it says if the remainder of synthetic division is 0, then the binomial is a factor of the polynomial. So what you want to do is just divide, use synthetic division, and divide and see if you get 0 as a remainder. So let's see if that happens. Let's set this guy up. We would put -3 in our backwards box. Remember, you set this guy equal to 0. That's your divisor. And then we have 3, 2, 1, none. So we have all of our exponents. So we have 1, 6, 8, -3. Draw a line, drop a line, leave a line, draw a line, drop your first number, and then multiply. So -3, +3, -9, -1, +3, 0. That's your remainder. Since this is 0, so yes, x plus 3 is a factor of x cubed plus 6x squared plus 8x minus 3. Okay, so that's what that means, if you get that. All right, moving right along. We got a few more examples we need to do, and Descartes' rule of signs is next. Okay, so we're going to go to a new page. This is a French dude named, I think his first name was Blaise, which is interesting. His last name was Descartes, and it is spelled Descartes. Well, it's TE, and then they added the S for the rule of signs. Okay, so we have Descartes' rule of signs. So what we're going to do is you're going to be given a function, f of x. So given a function, you are going to look at the number of sign changes in f of x. Okay, this will equal the number of possible positive real roots. In the function, and they will come in pairs. And we'll explain what that means in a little bit. Okay, so there's going to be a bit of writing here for this, and then we'll work through it. Then we will find f of negative x and look at sign changes. And I'll show you how we're going to do this. This will be the number. Oh, I forgot a B in there. I don't know why it erases so many of those. The number of possible negative real roots and these will decrease in pairs. Oh, this says come in pairs. They will decrease. Change this to decrease. And these will decrease in pairs. Okay, so here's an example. And there's a lot of mathematical language in here. Let's see. So given f of x equals 4x cubed plus 2x squared plus 3x plus 4 equals 0. And this is how this will look in varsity. Use Descartes' rule of signs to find the number of possible positive, negative, and non-real roots of the equation. Okay, so here's how I want you to start this. I want you to rewrite the equation on your paper. So you have 4x cubed plus 2x squared plus 3x plus 4 equals 0. And then I want you to go from term to term. And if it changes sign, write yes. And if it doesn't change sign, write no. So this is positive and it stays positive. So that's a no. Positive to positive, no. Positive to positive, no. Okay. So this has 0 sign changes. So 0 sign changes means no positive roots. So this will have no possible positive roots. Now, that will change stories as that changes. All right. Now, the next step, if we look back up at the notes, it says find f of negative x. So this is the next step that's going to happen. So what we're going to do is we're going to find f of negative x. And what that means is you're going to take the original function and plug negative x in anywhere there's an x. So we're going to go 4 negative x cubed plus 2 negative x squared plus 3 times negative x plus 4. And then we're going to simplify that. Well, what happens when we do that? A negative x, this guy, raised to the third power becomes negative. So this whole term becomes a negative 4 x to the third. But a negative x squared is a positive x squared. So this sign will not change. So this will stay plus 2x squared. What happens here? This negative x is raised to the first power. So it's going to do what to this sign? It will make that a negative. So minus 3x. This guy can't change because there's nothing on it. Oh, so plus a 4. Okay, so now we're going to look at sign changes in f of negative x. So the first thing you have to do is actually make this happen. You have to do this. Something you have to actually do. Plug in negative x for all the x's and then do the multiplication. Okay. You will find that if the exponent is odd, the sign is going to change on the coefficient. right? Because a negative raised to an odd power is a negative. But if the exponent is even, then it is going to keep that thing the same sign that it started at. It won't make a positive. It will keep it the same sign it started at. Now you're going to look at sign changes again. So we're going to go negative to positive. Well, yes, that is a sign change. Positive to negative. Yes, that is a sign change. Negative to positive. Yes, that is a sign change. So now we have 3, and then we have the statement that these will decrease in pairs. So, or 1. I'm going to write that down. So we start with 3. We have 3 sign changes, and then we're going to decrease it by 2. It can go down to 1. And what's happening there is whatever number you start at, if we started at 7, it can go down by pairs. So it could go to 5, then 3, then 1. It can't ever go less than 0. If you started at 6, it could go to 4, then 2, then 0. Okay? It's going to always decrease these in pairs. So whatever number you start at, the number of yeses. So 1, 2, 3 yeses. You're going to start with a 3 and then decrease these in groups of 2 until you get to either 1 or 0, depending on what you start with, an odd or even number. That's just the way these happen. Probably enough of you don't care to know why that happens, but what's going on here is you could have imaginary roots. They happen in pairs. So if you had imaginary roots, that might account for 2 of these, and then you only have 1 of these negative roots. And that's what's going to happen. So what's going on here? We get an equation. We are able to look at this now with a little more critical eye and say, oh, let me apply Descartes' rule of signs. And I can say, oh, I'm going to have no positive roots for this equation. I know because look what I just did. I'm going to have 0 positive roots to this equation. If I were to make my list of P's and Q's, I would be able to have an idea of what those roots would be. And remember, those were all plus and minus roots. I could eliminate all the positive possibilities, all of them, because this one wouldn't have any. And now I would know if I found one negative one, I could have 3. So I might have a few more. So if I found 2, I definitely have another one, right? I'm not going to have only 2. I'm going to have 1 or 3. So this helps me when I'm doing my synthetic division to find out how many actual roots I'm going to have. All right, so what you're going to see in varsity is you're now going to have a list. So in varsity, this is going to look like this. They're going to have 3 drop downs, and it's going to say positive, negative. Oh, that just messed that up. Just pretend you know what that says. And non-real. Well, non-real are imaginary. That's what those are. And we can have imaginary answers to these questions. All right, so here is how this is going to work. We know we have no positive roots to this answer. So you're going to have drop-down boxes. So I'm going to pick a 0 to that. And then I know here, because I got a 3 and it's going to go down by pairs, I'm going to have 3 or 1. Okay, now here's where this gets a little weird. Remember at some point, I'm sure we talked about the fact that, let me grab a yellow highlighter here. The number of the highest exponent is the number of total answers that you're going to have in this problem, right? So if I have 3 negative roots, that's all of them. I won't have any more, right? So if I have 3 here, I'm done. But what if I only have 1? What if I only have 1? Well, then what happens? The other 2 of them have to be imaginary, right? So I'm going to have 1 negative and 2 imaginary. But remember, everything's going to go down in pairs. So this could be 2 or 0, and that happens because if this is either going to be, let me highlight these for you. This will either be 1 and 2 to give me a total of 3 roots, or 3 and 0 to give me a total of 3 roots. That's what's going to happen here. So you have to be really careful and figure out how you're going to get different totals of 3, basically, to get the number of total roots that you need. Okay. I'm not going to go through a bunch of these. They take a little bit of practice, but they're not really very hard. We are going to do one more that's got 7 roots so that you can see another example. Okay. So one more. So we are going to use Descartes' rule of signs. Sorry, I forgot to put my phone on be quiet before I started this video. And it's morning, so I'm getting some texts. To find the number of possible roots. I don't know. Here's our big old equation. We'll do f of x equals 3x to the 7th minus 2x to the 6th minus 3x to the 5th plus x to the 4th minus 2x cubed minus 3x squared plus 2x plus 3. And there's an equal 0 on the end, but I'm going to ignore it. It's not very important. All right, so what I need here is sign changes. Now, this has no sign, so essentially it starts out as positive, right? So sign change. Well, yes, this changes sign. And then this one, negative to negative. No, that does not. Negative to positive. Yes, this does. And you could put Y's and N's. I'm just laying everything out. Positive to negative. Negative to negative. Negative to positive. And positive to positive. So I have 1, 2, 3, 4. So that means I'm going to have 4 or 2 or 0 possible positive real roots. Okay. The number of yeses and then decrease by 2. Now, the next step we need to do, find f of negative x. And remember, we do that by plugging a negative x in. So 3 negative x to the 7 minus 2 negative x to the 6th minus 3 times negative x to the 5th minus plus negative x to the 4th minus 2 negative x to the cube. Oops, I forgot the negative. Minus 3 times negative x squared plus 2 times negative x plus 3. All right, so here's what I maintained from earlier. If you have, and you guys can think about this as much as you like, if you have an odd, oh, I wanted to change that color, odd exponent, then you have a negative inside your parenthesis. A negative times a negative is a positive, but a negative times another negative is still negative. So what's going to happen on every one of these terms is essentially the sign will change on the front because of the negative being raised to a different power. And the ones with an even exponent, that's not going to happen because a negative to an even is a positive, And a positive times a negative in this case is still negative. So that sign's not going to change. So anything with an odd exponent, you can kind of shortcut these. This whole thing is going to change signs. So this is going to be a negative 3x to the 7th. This one won't change signs. Negative 2x to the 6th. This one is going to change signs because of the odd exponent. Positive 3x to the 5th. This one will not change signs, so we keep the plus. Plus x to the 4th. This one will change signs. Plus 2x cubed. This one will not change signs. Minus 3x squared. This one will change signs. Minus 2x plus 3. Okay, so now let's look at sign changes again. Negative to a negative. No. Negative to a positive. Yes. Positive to positive. No. Positive to positive. No. Positive to negative. Yes. Negative to negative. Sorry, that's a no. Whoa. Dumb. No. This was a yes. Okay, so this was a no. And then this guy is a yes. So again, we circle the yeses. 1, 2, 3. And these guys will go down in pairs. So 3 or 1. All right, so now in varsity, here's how it's going to look. Positive, negative, and then I think it says non-real. Okay, so our positives were these guys. 4 or 2 or 0. Our negatives, these guys. 3 or 1. All right, now let's look at what happens. So if I have, how many total should I have? I should have a total of 7 roots. So total of 7, right? So if I have 4 and 3, that means I would have 0. I'm just going to kind of make a list over here. I'd have 0 non-real. But what if I had 4 and 1? Well, that's only 5. Then I would need 2. If I had 2 and 3, that's 5, so I would need 2. But if I only had 2 and 1, that's 3. I would need 4 of them, right? And if I had no real, no positive, 3 negative, I would still need 4. But if I had 0 positive and 1 negative, then I need 6 non-reals. Okay, and these would be listed in opposite order. So I'm going to need 6 or 4 or 2 or 0. Okay, so that could happen, that you need that many. And you need to look at it that way. Take every single account of what could possibly happen. So this would be the answer to that question. Okay, let's see. All right, we have one more example here that we have to do, and then we can wrap up this video. And this specifically speaks to number 7, but I think it will give you some guidance for some other ones. Okay, so it says use what I wrote here in my notes. I said use synthetic division and then factor the binomial, depressed polynomial. I don't know what to say. And write your answer as 3 binomial factors. So use synthetic division, then factor the depressed polynomial. And write your answer as 3 binomial factors. Be sure to include the given one. Okay, so the one that I have says solve completely. It says x cubed minus x squared plus 4x minus 4 equals 0. And I think that's all it says. No, I can't imagine. Let's go pop over to, now this is going to be a different one. It might say solve completely. Oh, maybe I'm just telling you this in general for number 7. Use synthetic division, factor the depressed polynomial, and write your answer. Okay, be sure. This is a totally different question here for this one. All right, so solve completely. Well, there's a couple ways to go about this guy. You could like look at it, try to find your rational roots, do all sorts of things. But what I decided to do with this was to factor by grouping. Anytime you can solve by factoring, do it. So okay, so we're going to start like that. Remember, when you factor by grouping, you set up 2 groups of binomials, and then you factor out the GCF of each quantity. And then you have a common quantity, right? There's my common quantity. And then you have x minus 1 times x squared plus 4 equals 0. Then once you have it factored, you can set each factor equal to 0. So now I have this guy gives me x minus 1 equals 0, so x equals 1. This guy gives me x squared equals negative 4. So if I then take the root and take the root, I get x equals plus and minus 2i. And so here are my 3 answers to that. Here's 2 answers. So I have x equals 2i, x equals negative 2i, if I break those out, right? So here's 1 answer, 2 answers, 3 answers. I need 3. Okay? This is what we're doing. This is the whole goal of this thing, is to be able to solve problems completely. Solve them that way. All right, so here's another one. This is the goal of the class, be able to solve these problems. Solve x to the 4th plus 14x squared plus 45 equals 0. So this guy, use X method. If you don't like X method, you could use quadratic formula, but good Lord, what a pain. So you can have 45, you're 14, you know, this is 9 and 5. You're dividing by 1. In this case, it doesn't matter. Now, because this is an x to the 4th and this is x squared, these need to be x squared plus 9 and x squared plus 5 equals 0. Set each factor equal to 0. And then you have x squared equals negative 9. Take the root, and you get x equals plus and minus 3i. This one, x squared equals negative 5. Well, when you take the root and take the root, the I will come out, but the 5 won't. So you get x equals plus and minus I radical 5. So there's 2 answers. There's 2 answers. You needed 4 of them. None are real. This has no real roots because all of them are imaginary. Right? But there's an answer to that problem. So that's the goal of this entire thing. So the last couple problems in varsity look like that, where you need to be solving these things. Think factoring in order to solve. Okay? All right. That's it. Toodaloo.